I'm Zach, and today I'm going to be talking about gas laws. The first question is, what is a gas? Gas is a matter that takes the shape of its container and has no definite shape, volume, or size. How are gases different than solids and liquids? Molecules in gas spread out far apart, where in liquid molecules move fast but are close together, and solid molecules move slow and are packed tight. Gas has no definite shape, size, or volume, when liquid has a definite volume but no definite shape, and a solid has a definite shape, volume, and size. Boyle's law. The formula is below it. It's P1 times V1 equals P2 minus V2. Boyle's law states that pressure and volume of a gas have an inverse relationship, which temperature is held constant. The problem: if 22.5 liters of nitrogen at 748 are compressed to 725 at constant temperature, what is the new volume? First, you take 22.5 liters times 748, and then which equals 16,830. Then on the other side, there's 725 and the new volume you're trying to find. If you take 16,830 and divide it by 725, you'll get 23.2 liters. Charles' law. Charles' law states that if any given quantity of gas is held at a constant temperature or pressure, its volume is directly proportional to the absolute temperature. The formula is V1 over T1 equals V2 over T2. The problem: calculate the decrease in temperature with 6 liters at 20 Celsius is compressed to 4 liters. First, you change Celsius to Kelvin, so plus 273. Then you cross multiply with 293 Kelvin times 4 liters, and then divide that by 6, which gives you 195 Kelvin. Combined gas law. Combined gas law uses laws from Boyle, Charles, and Gay-Lussac. Boyle's law says that the pressure-volume product is constant. Charles' law shows that volume is proportional to the temperature. Gay-Lussac's law says that pressure is proportional to the absolute temperature. The problem: if I initially have a gas at a pressure of 12 atmospheres, a volume of 23 liters, and a temperature of 200 Kelvin, and then I raise the pressure to 14 atmospheres and increase the temperature to 300 Kelvin, what is the new temperature of the gas? First, you move the formula to where the problem set up as V2 equals P1 times V1 times T2 over P2 times T1. And filling in the numbers, you'll have 12 times 23 times 300 over 14 times 200. Once you multiply the top to its own total and the bottom to its own total, you divide them and come out with 29.6 liters. Ideal gas law. For ideal gas law, P is pressure, V is volume, N is the number of moles of molecules, T is the absolute temperature, and R is the gas constant. For the problem: if I have 4 moles of gas at a pressure of 5.6 atmosphere and a volume of 12 liters, what is the pressure or temperature? First, you have to switch it to where, arrange the formula to where T equals PV over NR. So putting in the numbers, you put at the top 5.6 for the pressure. Then for the volume is 12 liters. And then you have the gas constant for at the top. And at the bottom, you put 4 for the moles and then 8.31 for the gas constant for that one. And then multiplying the top and the bottom by their numbers and then dividing it brings you to 204.8 Kelvin, or switching it back to Celsius is negative 68.2 Celsius. What is Kelvin scale and why do we use it? Kelvin is a temperature scale designed so that 0 degrees is defined as absolute zero. Kelvin is the prime measurement and is often used in conjugation with Celsius. How do we convert from Celsius to Kelvin and back? Celsius to Kelvin is adding 273, and Kelvin to Celsius is subtracting 273. What is absolute zero? It's the lowest temperature that is possible. The motion of particles that have heat would be minimal, and it's 0 on the Kelvin scale. STP. What does STP mean? It stands for standard temperature and pressure. What are the temperature and pressure at STP? The temperature is 273.15 Kelvin and the pressure is 100 kPa. What is the purpose of the ideal gas constant? It's to find out the behavior of the gas under the ideal conditions. It depends on the problem. What are the values of ideal gas constant are, and in which circumstances would you use each? The values are the one in the box. You use each constant with the information in the problem, so it depends. And the information in the problem are the ones in your constant. If you have L, ATM, K, and moles, you will use the first one. And if you have Cal, K, and moles, you would use the last one. And that is all for learning of the gas laws. I hope you enjoyed it.